In this class, we have to learn about the law of mechanics. Actually, the mechanics is mainly deal with the forces and their influences on the uh, matters. Here, the matter representing the which one? The particle as well as the rigid body. So the mechanics is mainly deals with six kind of basic laws. Here, the Newton influencing this subject very much. So Newton's first law, second law, third law, which is influencing the forces and its influencing on the particles, right? And the other three are Newton's law of gravitation and Newton's law of transmissibility of forces and parallelogram law of forces, right? So, according to the Newton's first law, what is Newton's first law saying? Newton's first law is nothing but an object in motion will stay in motion, right? And an object is at rest that will stay at rest unless acted upon by an outside force, right? This is the Newton's first law representing. Okay. So here we can see two figures, right? The topmost figure, the ball is under rest. Okay. Therefore, the ball is at rest will remaining at rest unless a net force which is acting on it. Okay. The bottommost area, the particular ball is under motion. Okay. That means the particular ball is under motion. That means will remain in motion unless a net force which is acting on it. This is about the Newton's first law. Okay. Then we can go for the Newton's second law. Newton's second law is very simple. It is F is equal to m into A, where m is nothing but mass of the particular object and A is the acceleration due to gravity. So what is Newton's second law says? Newton's second law says that the acceleration of an object mainly depend upon the variables. That means the net force acting on the object and the mass of the object. Okay. Here there are two figures. Okay. So let us consider the first one. The mass of the particular figure is m1, and we will give the force on the particular object is f1. So compared with the second figure, the mass of the object is a little bit low. That's why we can give the minimum amount of force on the particular object, right? And consider the second figure, the mass of the object is a little bit big, which is compared with the first one. That's why we can give the much force which is compared with the previous F1. Therefore, the F2 is generally greater than F1. And as per the representation of these figures, the M2 is greater than M1. Okay. Therefore, F is directly proportional to the mass. Okay. This is the Newton's second law representing. And then we can go for the Newton's third law. The Newton's third law we are using in a day-to-day life. Okay. So for every action, there is an equal and opposite reaction, right? Say for example, we all know about the gun shooting. Okay. Actually, during the time of shooting of the gun, the pellet is having a velocity, a huge velocity of forward direction. The same time, there is a recoil which is created on the gun itself. Okay. The shooter can feel the recoil. Okay. So that is called reaction. Here the action is the acceleration force on the pellet, but the reaction is recoil of the recoil which is happened in the gun. Okay. This is about the second law. These three are the different examples, right? The first one, first law says that if a body is under rest or under motion, which is acting any force, any external force which is acting on it. Okay. About the second law, the mass is the major influencing parameter. Therefore, F is proportional to M, and the acceleration is also proportional to the force applied. That is about the second law. And about the third law, there is an action, we have the equal and opposite reaction. That's why if the force applied with the green arrow representing force of AB, and we can consider the force of pink arrow, which is represented by force of BA, means the Newton's third law representing F is equal to minus F, or FAB is equal to minus FBA. Okay. Then we can go for the Newton's law of gravitation. Okay. So what is Newton's law of gravitation? Newton's law of gravitation is nothing but an a particle of a matter in universe attracts any other with the force varying directly as the product of masses and inversely as the square of the distance between them. That means, let us consider the black color ball which is having the mass of m, and the blue color ball which is having the mass of m2, and the distance from the center to center is small d. Then the law of, as per the law of gravitation, Fg is equal to g into m1 into m2 divided by d square, right? Where the value of g is nothing but 6.61 into 10 to the power minus 11 nanometer per kilogram square. This is the Newton's law of gravitation, right? Then we can go for the next law, that is principle of transmissibility. This is nothing but there is no change in equilibrium state of the body when the point of application of forces on the body is transferred to other point on the line of action of the force without changing the direction. Okay. Consider these two diagrams. The first one, there is a force vector F. Its line of action is denoted as the dotted line. Okay. So the second diagram, yellow block representing the same line of action dotted line, but we can give the force vector in the bottommost side of the body, right? We can explain a little change, okay? That means if we have to move a body with the help of a push, we have to have a pull, okay? That means if we have to give a push or pull with the same direction or same line of action, when we have to measure the point at which the dotted line is same, when we are considering the force which is having the pull option or push option, okay? Therefore, it is representing the same magnitude, same direction, as well as same line of action when we have to measure the forces and its magnitude at any kind of its line of action. That is called the principle of transmissibility, okay? Then finally, we can have the parallelogram law of forces, okay? What is the parallelogram law of forces? It means if two forces acting at a point are represented both in magnitude and direction by two adjacent sides of the polygon, then their resultant is represented by the diagonal of the parallelogram drawn from the same point, okay? We can explain by a simple example. Let us consider the p vector as well as the q vector. Then, as per the parallelogram law of forces, we can fix the both vectors as a common point called O, and here the two vectors are starting from O point. So OP, OA, which is represented by P vector, as well as OB is represented by Q vector. Okay. Here we can consider the two forces are related with the representing the two sides of the polygon. Then their resultant vector R is represented by a simple formula called R is equal to root of P square plus Q square plus 2PQ cos theta. These 6 are the very basic law about the engineering mechanics, right? So thank you so much for the participation. So at the end of this class, we can have a knowledge about the law of forces. Thank you.